Today's lesson is still on probability distributions, but we're going to look at a special discrete probability distribution known as the binomial distribution. Do you still remember what is a Bernoulli experiment? A Bernoulli experiment is an experiment which has only two possible outcomes, which is success or failure. For example, when you toss a coin and you want a hit, so it's either you are successful in getting a hit or failure of getting a hit. If we have an experiment involves an independent Bernoulli trials, and X is the number of successes, then X is said to have a binomial distribution. Okay, let's look at the symbol. X is binomially distributed with parameters n, p. So what is n? N is the number of trials. P is the probability of success. So remember class, our X is a discrete random variable. If we have a distribution X which is binomially distributed with parameters n, p, then the probability of obtaining R successes from n trials is given by Px equal R is NCR P to the power of R multiplied by Q to the power of n minus R, where R is the number of successes, so R can take the value of 0, 1, 2 until n. P is the probability of success, and we know that P must lie between 0 and 1. And Q is the probability of failure. So how do you find Q? Q is equivalent to 1 minus P. Okay, we look at the first example. Okay, look at your handout given in your Google Classroom. So if we have X binomially distributed with 6 as the number of trials and 0.4 as the probability of success, so you need to find the probability of X equal 5, the probability of X equal 0, and the probability of X greater than 4. So recall back the formula. The probability of X equal R is NCR times P to the power of R Q to the power of n minus R. So your n here is 6, your P 0.4, and your Q is 0.6. So the first question, finding the probability of X equal 5. So substitute R as 5. Okay, you evaluate. You have 0.03686 rounded off to 4 significant figure. Part B, the probability of X equal 0. Substitute R as 0. You have 6C0 multiplied by 0.4 to the power of 0 multiplied by 0.6 to the power of 6. Now 6C0 is 1. 0.4 to the power of 0 is 1. So all you need to do is find the value of 0.6 to the power of 6, which is 0.04666 rounded off to 4 significant figure. And lastly, we have probability of X greater than 4. Since this is discrete and n is 6, so you have Px equal 5 plus Px equal 6. Now your Px equal 5 you have obtained earlier to be 0.03686. So all you need to do is find the probability of X equal 6, which is 6C6. Again, 6C6 is 1. 0.4 to the power of 6 multiplied by 0.6 to the power of 0. So evaluating, you have 0.040956. Okay, the second example, you can read the question in your handout. Here a fair coin is tossed 5 times. Find the probability that a head appears 3 times, a head appears less than 3 times. Now, before we look at the solution, what is the probability of getting a head? It is just 1 over 2 or 0.5 because we have only two possibilities which are a head or a tail. So it's 1 out of 2. Let's define our random variable x as number of head appear. So your x is binomially distributed with n 5. Why n is 5? Because the coin is tossed 5 times. It's tossed 5 times. And the probability of getting a head is 0.5. So your p, a small p, is 0.5. Okay, now let's look at the question. Find the probability that a head appears 3 times. So your mathematical sentence is the probability of x equal 3. So substitute into the formula, your r is 3, your n is 5, your p is 0.5 to the power of 3, and your q is 0.5 to the power of 2. So you calculate, you have 0.3125. Okay, part B, the question asks, find the probability that a head appears less than 3 times. So how are we going to write the mathematical sentence? Yes, px is less than 3. So we know that when px is less than 3, your px can be 0 plus px equal 1 plus px equal 2. Now you can use this method too, but I feel that it is tedious because you need to find px equal 3 plus px equal 4 plus px equal 5, and you need to subtract by 1. Okay, so it's going to be tedious. Okay, now substitute into the formula. Your r is 0, your r is 1 in the second one, and your r is 2 for the third probability. So you calculate. Okay, this is px equals 0, px equal 1, px equal 2. You have the probability as 0.5. Example 3. 2% of the batteries produced by a factory are not satisfactory. In a sample of 12 batteries chosen at random, find the probability that exactly 3 batteries are not satisfactory, and find the probability that less than 2 batteries are not satisfactory. So if we look at the question again, you are given a sample of 12 batteries. So in other words, your n is 12. And then you are given that 2% of the batteries are not satisfactory. So what does this mean? It means that the probability of getting a battery which is not satisfactory is 2%. 2% is equivalent to 0.02. So now let's look at the complete solution. Again, you have to define your x. So your x is the number of batteries which are not satisfactory. And your x is binomially distributed with n12, and the probability of getting a battery which is not satisfactory is 0.02. So your n is 12, p is 0.02, your q must be 0.98. Okay? So the first one, what is the mathematical sentence? Px equal 3. Because exactly 3 batteries are not satisfactory. So again, you substitute into the formula, you evaluate, and you have 0.001467. You round off to 4 significant figure. Okay, the probability that less than 2 back 3s are not satisfactory. So the mathematical sentence is B, part B, Px less than 2. So since this is discrete, Px equals 0 plus Px equal 1. Okay, so it's very important that you look at the inequality sign. So again, you substitute into the formula. Okay, so you have 0.9769, you round off to 4 significant figure. Okay, now we look at the next example. Question 4. Here you have a box contains red marbles and green marbles in the ratio 1:2. So 5 marbles are drawn from the box one by one with replacement prior to the next marble is drawn. Okay, so find the probability that exactly 4 are red marbles, more than 2 are green marbles. Okay, so this is a good example whereby the first part of the question is stating red marbles, the second part is green marbles. So how are you going to define your discrete random variables? Okay, let's look at the solution. Now I'm going to find my random variable x as number of red marbles drawn. Okay, you can choose x as number of green marbles, but I prefer red marbles because it's easier for us to calculate. So x is a binomial distribution with n5 because the 5 marbles are drawn from the box one by one. And the probability of getting a red marble drawn is 1/3. Now, how do I get the value 1/3 when in the question it does not state the amount of red and green marbles? But we have the ratio. The ratio of the red is to green marbles is given as 1:2, meaning that the red marbles is to green marbles in the box is 1 part red and 2 parts green. So the total is 3 parts. So we have red marbles is just 1 part out of the 3 parts. So we have 1/3. So now your n is 5, your p is 1/3, your q is 2/3. We can solve the first question. Find the probability that exactly 4 are red marbles. So we translate into mathematical symbol p x equal 4 because exactly 4 are red marbles. Substitute into the formula. Your r is 4. So 5c4 times 1/3 to the power of 4 times 2/3 to the power of 1. Here, writing 1 is optional because 2/3 to the power of 1 is still 2/3. So you solve, you have 10/243. Now for the second question. More than 2 are green marbles. Are you going to define another random variable? You can still use x as number of red marbles drawn. But how do you write? Now, you need to get more than 2 green marbles. So ng must be more than 2. So in other words, your number of red marbles must be less than equal to. So you can write your mathematical symbol as probability of x less than equal to, which is px equals 0 plus px equal 1 plus px equal 2. So you substitute. The first one r is 0, second one r is 1, the third one r is 2. Okay, notice that the first value here, it is written 2/3 to the power 5. Why? Because 5c0 is 1. 1/3 to the power of 0 is also 1. So all you need to find is 2/3 to the power 5. And you add up with the rest of the values of the probabilities. So you have 64 over 81. Example 5. A multiple choice test consists of 8 questions with 5 answer choices each. Each question has only one correct answer. If a student answers all the 8 questions by guessing, find the probability that the students will get all the questions wrongly and the students will get more than 6 questions correct. So we look at the information given in the question. Okay, the students answer all the 8 questions. So your n is 8. Now, each question has 5 answer choices, and each question has only one correct answer. So the value of P that is getting one correct answer is 1 out of 5. Okay, let's look at the solution. So let's define our x as number of questions guessed correctly. So your x is binomially distributed with n8. And the probability of guessing one question correctly is 1 over 5. Okay, your n is 8 because there is 8 questions. Your p is 1 over 5. One answer is correct out of the 5 answer choices, and q is 4 over 5. Now the first question asks the probability that the students will get all the questions wrongly. So your px is 0 because all the questions are guessed wrongly. Hence, substitute your r as 0 into the formula. So you have 8c0, 1 over 5 to the power of 0, 4 over 5 to the power of 8. So the answer is 0.1678. You round off to 4 significant figures. Okay, part B, the students will get more than 6 questions correct. So we have px greater than 6. So we have px equals 7 plus px equals 8. So px equals 7, your r is 7. So substitute your r as 7. Okay. So you have 8c7, 1 over 5 to the power 7, 4 over 5 to the power 1, plus 8c8 times 1 over 5 to the power 8 times 4 over 5 to the power 0. And you have 0.000084448. Okay, we look at example 6. You're given that x is binomially distributed with n number of trials, and the probability of success is 0.05, and that the probability of x greater equal 1 is greater than 0.5. So find the smallest value of n. Okay, we look at the solution. Okay, look at the information given. Px greater equal 1 is greater than 0.5. So we use that information. Now, Px greater equal 1. We don't know what is our number of trials. So we work backward. Px greater equal 1 is the same as 1 minus Px less than 1, which is greater than 0.5. Now, what is the probability of x which is less than 1? Is the probability of x equal 0. Okay, 1 minus px equals 0 greater than 0.5. Okay, substitute your r as 0. Now, nc0 is 1 here. 0.05 to the power of 0 is also 1. So you have 1 minus 0.95 to the power of n is greater than 0.5. So when you bring your 1 to the other side, is 0.5 minus 1, we have negative 0.5. So when you divide with a negative value, your inequality changes direction. Remember this, when you divide with a negative value, your inequality changes direction. Okay, so you have 0.95 to the power of n less than 0.5. Okay, so you have n log 0.95 less than log 0.5. Okay, you take log base 10 on both sides. You can use ln. Okay, ln, log base e is ln for the solution. Okay, hence you evaluate now. Log 0.95 has a negative value. Log 0.95 has a negative value. So when you divide with a negative value, your n must be greater than log 0.5 divided by log 0.95, which is 13.51. So your n must be an integer. It cannot be a decimal value. So your n is 14. The first integer after 13.51 is 14. Okay. Example 7. The probability that a football player scores a goal when a penalty is given is 0.6. Find the number of penalties which must be given before the probability of scoring at least one goal is more than 0.99. Okay, example 7, the question is very wordy. So you have to extract the information in the question and translate that into mathematical sentences. We define our x as number of goals scored. So your x is binomially distributed with n. N is the number of penalties taken, and 0.6 is the probability of scoring a goal. Now, if you were to look at the question, the information given is that the probability of scoring at least one goal is more than 0.99. So we write down the information. The probability of scoring at least one goal is more than 0.99. Now we translate this into a mathematical sentence. So the probability of x greater equal 1 is more than 0.99. Now we know that the probability of x greater equal 1 is the same as 1 minus the probability of x less than 1. And it should be more than 0.99. And we know that probability of x less than 1 is px equal 0. So you substitute to find your px equals 0. So you have 1 minus nc0, 0.6 to the power of 0 times 0.4 to the power of n, which is greater than 0.99. Okay, you simplify. We have 1 minus 0.4 to the power of n must be greater than 0.99. Again, when you bring your 1 to the right hand side, we have 0.99 minus 1 is negative 0.01. So we have negative 0.4 to the power of n greater than negative 0.01. So when you divide with a negative value, so you have 0.4 to the power of n less than 0.01. Remember, when we divide with a negative value, your inequality changes direction. Now, taking log to base 10 on both sides, or you can take log to base e on both sides. So you have n log 0.4 is less than log 0.01. Your log 0.4 is a negative value. So when you divide with a negative value, again, your inequality changes direction. So log 0.01 divided by log 0.4 is 5.026. So your n must be greater than 5.026. So the first integer after 5.026 is 6. Hence, the minimum number of penalties is 6. Okay, notice that when you write down the solution for log in terms of log 0.01 divided by log 0.4, please do not evaluate the value. Remain as it is because log 0.01 is already a number. Okay, similarly log 0.4 is a number. You don't have to evaluate. Okay, that's all. Okay, now we look at the mean and variance of the binomial distribution. Okay, since this is discrete, so the mean is x. The mean is the expected value of x, okay, which is just NP. Okay, and the variance is variance of x, var x is NPQ. Okay, let's look at example how to use this formula. Okay, look at example 8. Given the probability that a durian chosen at random from a basket is rotten is 0.08. Okay. Find the expectation and standard deviation of the numbers of rotten durians in a sample of 20 durian chosen at random from the basket. Okay, try to extract the information in the question. Okay, let's define our x as number of rotten durians. Okay, now look at the questions. We are given number of rotten durians in a sample of 20 durians. And that the probability of choosing at random a durian is rotten is 0.08. So we can write our x as binomially distributed with n20, and the probability of getting a rotten durian is 0.08. Now you need to find the expectation of the number of rotten durians. So the expectation is EX, which is NP. So your N is 20, your P is 0.08, you multiply, so we have 1.6. So the expectation of getting durians which are rotten is 1.6. Okay, now to get the standard deviation, we find the square root of the variance of x. The square root of variance of x is the square root of NPQ. So you substitute your N as 20, your P as 0.08, and your Q as 0.92. Multiplying, you have square root 1.472, and the value is 1.213. Example 9. A fair die is thrown 60 times. Find the number of times the number 6 is likely to appear and calculate the standard deviation. So when we say the number of times number 6 is likely to appear, it means find the expectation the number 6 is likely to appear. So as usual, define your discrete random variable x. So I define as number of times number 6 appears. So what is the probability of getting a 6? 1/6. So your x written in a mathematical symbol is binomially distributed with n 60, and the probability of getting a 6 is 1/6. So find the expected value of getting a 6. It's just NP. Substitute n 60, your P 1/6, so you have 10. And then to find the standard deviation, again, you find the square root of the variance of x, which is the square root of NPQ. So you substitute your n 60, your P 1/6, so your Q must be 5/6. So you find the square root to be 2.887. Okay, let's look at the last example. Example 10. We have a binomial random variable x with parameters n, p, and the mean is given as 3 and the variance is given as 51/20. So find the values of n and p, hence or otherwise find px equal 3. So in the question, notice that we have the task word hence here. So what does this mean? It means that you have to use the values of n and p obtained earlier to find px equal 3. You are given in the question the mean of the random variable x is 3. So the mathematical expectation of x is 3, which is np equal 3. So this will be your first equation. And you're given that the variance of x is 51/20. So your NPQ is 51/20. So this will be your second equation. Now you can either substitute equation 1 into 2 to get your Q, or you can divide equation 2 with equation 1 to get your Q. So here I'm using equation 2 divided by equation 1. Okay, NPQ divided by NP, I have the value of Q, which is 17/20. So to get the value of P, is just 1 minus Q, which is 3/20. So now you have the values of P and Q. So to find the value of N, we substitute P into the first equation. N times 3/20 is 3. So evaluating, the value of N is 20. Okay, now you have already find the values of N as 20, your P as 3/20, and your Q as 17/20. So you have to use this value to find the probability of x equal 3. So substituting all the values into the formula, you calculate and you have 0.2428. Okay, class, that is all for today. Thank you.